Hi, everyone. Thanks for joining. I think we have quite a few folks on the line, so we could get started. Um, so our first topic today is on this issue created on size switch attribute FTP table size. Krishna, I think, please go ahead. Yeah, I can
Yeah,
see it.
yeah. Thanks, Tejashni. Good evening, everyone. Uh, this topic is regarding the description of the FTP table size attribute. The description says the size of the FTP table in bytes. So we got confusion here while implementing this attribute. So if you see the other attributes like L3 neighbor table size and L3 route table size, they are clearly mentioning the size of the table. Nothing other than that. They are not mentioning in bytes and like that. So the query is, should it be the size of the FTP table, the number of entries and stuff in bytes? I hope the query is clear, or if you want, I can repeat again.
I think, do you want to uh, raise a PR for this?
Yeah, I want to raise if there is no concern and if everyone agrees that the size of the table should be number of entries instead of bytes. Is there any specific reason which we are not aware of? Um, Any history on this previously?
Um, I think
Eh,
so I don't hear any concerns here.
Okay,
So please go ahead with the PR for this.
okay, sure. We can move to the next topic, I think, right?
Okay, yeah.
And
Thanks,
stop
Krishna.
sharing.
Yeah.
Yeah,
Okay, next topic is on the MACsec and IPsec FIPS compliance. Jay, are you going to present?
Yeah, hi Tejasvi, thank you. Hi everybody. So today I will be talking about the enhancement on the MACsec and IPsec size specification. Let me share my screen. So the PR is already raised. So I will go a little bit slowly on this. There are many details there that are subtle in this, but just to give a brief overview, what we are trying to do today, there is MACsec, and the proposal is very symmetrical to IPsec and MACsec. So I can just pick one object and just talk about it, and same thing will apply to IPsec. So let's say that there is a MACsec engine. Hardware architecture is where MACsec engine is serving more than one or possibly one MACsec ports, right? So there's a binding of an engine to ports, which can be 1 to n or 1. So that's the hardware construct. And what FIPS compliance requires is that before the port becomes the MACsec port, when I say I'll use port constantly, but essentially it's in a context of MACsec, so it's a MACsec port. If I need to use a physical port, then I'll call it a physical port. So just be careful about the terminology. So before the port becomes operational, it need to pass the post, which is during the system init time. And once the post is passed, after that, the port becomes operational to pass the MACsec traffic. Okay. Before that, port may be coming up in a bypass mode, right? So that's the FIPS compliance. And then and there are details on the FIPS compliance itself, which I have not gone in this doc. Uh, the the domain of the compliance, the boundary in which compliance need to be a very tight boundary, meaning that the modules which are certified for FIPS compliance may stay in a tight boundary. And anytime you do any change, then they need to go through the compliance certification again. So typically, that boundary is contained within the SDK domain, and we do not want to expand that boundary into Psi or even in NOS, right, in Sonic. What it means is that if there is uh, any action which need to be taken as part of compliance failure, let's say the port is being bought up for post and post fails, and port need to be kept in a admin down state where port is not operational for passing the traffic, that action need to happen local within the SDK boundary, right? Or I should not say it's SDK boundary, within the FIPS certified boundary, and in a very tight domain, right? So you will see that some in my document I'll say, okay, if the post fails, then port must be not operational for traffic. That not operational for traffic is actually the action taken into the lower layers. That is not bubbled up. It's not that Sonic has to trigger action and bring the port in a down state. So those are the kind of subtle things which you will see in the document, but I just wanted to highlight. So before I start, any top level questions? Okay, if not, and you can interject me any point. So I'm going to read the document line by line so that it's a little easier to understand. So this document describes the SI API interaction and enhancements for triggering post for FIPS 130, 143 standard compliance to overall security level 1. Right? There's just a statement that what we are trying to do. NOS need to have cryptographic software components. These are called as libraries, which is a module providing cryptographic algorithm implies FIPS inside approach in the NOS. FIPS inside approach is the localized approach which we talked about. It's a type domain. The FIPS inside is a way of designating one or more crypto modules with smaller boundaries instead of one product-wise perimeter, as I explained earlier, which would encompass non-cryptographic components inside, all of them having a code freeze caveat. So once there is a certification done, that is a code freeze, right? You cannot change. Even a dot change will trigger a new certification. It won't be FIPS compliant. This document proposes a size specification that will be at the MACsec IPsec engine boundary, where a single engine may be serving multiple MACsec or IPsec ports, or there may be one-to-one binding of the engine to the MACsec IPsec port, as I mentioned earlier. Current size specification already supports the concept of MACsec and IPsec objects and ports. It also supports the concept of one-to-one binding to engine, of engine to port, and or engine servicing to more than one ports, where engine is the MACsec, and I'm qualifying the statement because I'll use it interchangeably a lot, where engine is the MACsec IPsec module, and the port is corresponding MACsec IPsec port. Okay, so whenever I say module or engine module, it may imply either one of them. Port, it will imply MACsec IPsec port. This is a bring up sequence which happens as of today, okay, without any FIPS compliance. So in this, first we do a switch create, and a switch create will also include creation of ports, etc. The physical ports, followed by the MACsec IPsec object instances are created. Each object IPsec instance is serving a physical port, which will be binded through the MACsec port object. So you create the port object, SA bindings are done, etc. Attributes are done, and when the SA binding is complete and authentication is complete, then the port as in the MACsec port is ready for the RxDX traffic. Okay. So this is a very coarse level granularity, right? There are a lot of things in between happen, but more or less this is what the flow is. So this document introduces a stage called as a pre-operational self-test before the port as the MACsec port is operational to RxTX traffic, right? FIPS 103 compliance requires that post is executed on each port, and only if post completes with success, port must be enabled for admitting traffic, else port will remain in downstate. So again, port is a MACsec port. It's not a physical port. There is a little bit of a ambiguity in the statement on a MACsec port level. If you see, there is no concept of upper state, right? The upper state are at the physical port level. What this means is that port should not be admitting traffic, and how that state is achieved is left to the FIPS boundary, right? It's left to the SDK, lower level. And that's implementation specific. We don't specify here that how this state is achieved. As far as the size concerned, MACsec port don't even have upper state. But end result should be the post fails, then port should not be able to forward the traffic. Okay. Any questions? Just feel free to interject. I'm just gonna go a little bit, quick on this.
So
There are two variations of MACsec IPsec engine. Any question?
I do have a, sorry, Judy, go ahead.
Okay. No, the question I had was, I think, so I think, Jay, in your sequence, we create everything, right? We create all the MACsec object, the port, and the MACsec port object created. So after that, we are doing the post. So these objects are all created, and then if
No,
post fails, we don't.
I have not come to that point. This
Oh,
is how it's today without any post.
So,
Okay.
so Jay, I
okay.
had a comment too. So just for clarity, then instead of saying port, could we just say MACsec port or
Yeah, I
basically
qualified
port being in downstate kind of?
yeah, the verbiage becomes too liberal there. So
Yeah,
physical
I
port
mean,
I will qualify as a physical port. Otherwise, port is this I qualified very early.
okay. And the second comment is on the previous paragraph, it says that the post before the port is operational to RxTX traffic, right? Cannot that be relaxed to say that the post must be done? I mean, either you can say it's extreme is that you always do it at initialization. The other extreme is that you have to do it before you enable MACsec on any port, right? Or MACsec or IPsec on any port.
Yeah, Dipankar, if I may request, just add comments to that.
Okay.
I think that should not be a
I
problem.
will do that. I will do that.
There are two variations of MACsec IPsec engine we talked about, right? This is just a conceptual diagram that how packet processing engine will look like with a port serving. So here the security engine is serving more than one ports. That's conceptual. Excuse me, my allergies are bothering me. Okay, so Psi object type MACsec and Psi object type IPsec already exists, and they have a binding to the port list. And these are the MACsec port lists. So MACsec address supported port list and IPsec address supported port list. These provide the list of ports being serviced by the instance. Okay, and these are MACsec port. And if you go in the each port object, then you will see a reference to the physical port. Okay, and remember, when I say I always port means MACsec port, and physical port is referred as a physical port. Psi workflow always first initializes the MACsec engine object before triggering post on all the ports being hosted by the Mac. Now, this is, I feel, and I'm looking on these two statements. I'm looking for expert advice, people who understand the MACsec engine well. I feel this is implementation specific. Right? So the statement is saying Psi workflow always first initialize the IPsec engine object before triggering post. I feel that hardware may not need the engine initialization. We may have to create the object in the Psi, but initialization of the engine is probably implementation specific. Post may be able to run even before the engine is initialized. And I don't know if this is hardware specific. We should relax this statement, right? till the post is complete, uh, for all the till post is complete for all the MACsec IPsec ports is complete, comma. All the MACsec IPsec ports are in a down state. And these are MACsec IPsec ports. Down, again, there is no upper state, right? Down as in that MACsec port is not ready to admit the encrypted traffic, right? So I'm looking feedback on in these two statements. I feel that they may have a little tighter definition, and this is just a statement, right? As far as the size spec is concerned, flow is controlled by the NOS, right? So, but this need to be clarified. Dipankar, what do you think? Is this okay, or do you think they should be relaxed?
I think there could actually it could be much more relaxed, saying that it doesn't even have to be NOS visible, right? Because if let us say during initialization of a chip, there's an initialization file, and in that the post is run and the state is maintained. So in that case, a SCI call could be a dummy call, which is basically returning a status of a post already run.
Right, right. Yeah, so if you can just add some comments onto that.
I will do that.
Yeah, what's your thought process on this? Then I can adjust this as well. I also felt that I was reading it over again, that this is a very specific implementation specific, very tight statement. Sorry, any other comments?
No, but in the document, Jay, you were mentioning like the post is bound to the port, right? I think the port list is bound to the PSI object, like the MACsec PSI object. So we
Correct.
need to create that object first, right? I think that's the sequence which you shared here. So
Yeah, object creation is
slightly,
okay. Right. But what does it mean? Does it mean you have to go and initialize the hardware as well? Right? That's relaxed. That need to be relaxed.
okay, got it. Mhm.
And as Dipankar was saying, that typically post is gonna run the moment you create and set a trigger. I'll talk about the trigger. The post is gonna run immediately. And typically, as far as I know, that, and I again, as I said, I am not a subject matter expert on this. Uh, it can run even before the engine is initialized. It can take some small metadata, the post, strings and keys, and can run the post. So this is like almost theory of operation till now. We are going to go into the actual enhancements. All right. So what we have done, we have to trigger a post, we need a trigger point. Okay, so when the system is coming up, switch create happens, MACsec port engine is instantiated in the PSI object. Then we need a trigger, right? Trigger is a way to start the post. Okay, and that trigger is also helpful for other use cases where after the system is all up and running, for debugging, etc. You want to run the post again, so you can create an environment to again run the post. Now, how much it's used and how it's used, I think that depends on the use cases, but PSI specification does not preclude from doing that. Okay. So each MACsec engine is represented by MACsec PSI object. Single MACsec object can be serving one or more MACsec ports. This is just a reassertion of the previous statement. New read-only PSI MACsec at a post status attribute is introduced to read the completion status of the MACsec object post. So completion status of the post on the MACsec, the language is not clear. So once the post is complete on a MACsec object, for all the ports being served by this MACsec object, there is a status available on a MACsec engine level. Okay, the details will come that how the status, when it should be read, etc. Note that status reflects the aggregate status for all the ports served by this MACsec object. Even if a single port fails the post, status of the MACsec object will be returned as PSI MACsec post status fail. What it is saying that an implementation may have variation where one port failing may trigger all the port failing, right? That's one variation of the implementation. In that case, the MACsec engine post status will match with the port status. Okay, but if there is an implementation where it is able to segregate operational state of a port where posts pass or fail, then engine reflects the aggregate status. If all the ports pass, then it say pass. And if any port fails, then engine will say its status is failed. And then to find out which port has failed the post, NOS has to trigger a walkthrough for all the ports being serviced by that engine, right? That's what it means. Okay. So this is the post status. This is simple. There are four kind of status. Unknown is basically a system init state. System has come. We don't know what happened. Is all unknown. Post is triggered. Post status is passed. Now, if the engine is serving large number of ports, and usually they don't take that much of time, but it's possible that it's taking time, and NOS comes and tries to read the status, it should be able to get the status in progress, meaning that post is still running. Or if the post fails, then post fails. So that's the status on an engine level. The next attribute is the trigger. I think I forgot to talk about it. I'll add a comment to talk about this trigger as well. So this is the, I think I did not mention explain this attribute. So this is the another attribute which is essentially a trigger. And if you see, trigger is kept at an engine level. And as I said, that engine may have a one-to-one binding or one-to-n. So when post is enabled on an engine, it will trigger post on all the ports serviced by this engine. And this method takes care of both the hardware variation where you have a one-to-one or one-to-n. Okay. And this is pretty simple. It's a bool. Sonic will trigger the value of this attribute as true, and psi, the moment it sees true, it will trigger the sequence of post using the FIPS library in the domain. So that's at the MACsec object level. Let me go to the port, and then it will complete one sequence. Then I'll pause for questions. So control, as I said, the trigger is at the engine level. At the port level, all you have is the port status, right? As I said, that once the post completes, engine has an aggregate status. The port, MACsec port, they have the granular status, per port status. And this is to support multiple variations of the hardware flavor. At the port level, you don't see any in progress. And the reason is that port status will be available only when the post completes, and nobody will read the if somebody reads, then the status will be unknown, right? The engine is post is running at the engine level. So you have three status here: unknown, where if the port is scheduled for running post and it's not even started or completed; pass, and nothing very fancy. So so far what we have completed, that NOS will come, MACsec object is created. It does not mean that hardware is initialized. The MACsec engine is initialized. It will set the post. This will trigger a post. Okay. And once the post completes, then we have a status available at the object level, at the port level. Now, how does the completion status is made aware to NOS, right? So I'm going to jump over that. I'm going to skip the IPsec. IPsec is just a cut and paste. Completion callback. Since aggregate callback function is provided to return the status of post status for all the entire MACsec or IPsec engine, so single aggregate callback function is provided to return the status of post status for entire MACsec. Okay. If the engine is servicing a single port, then this callback essentially becomes a per port callback. If the engine is servicing multiple ports, then each port needs to be queried for its post status using the read-only attribute of the post, as I explained earlier. Okay. So there is the callback. Excuse me. And this is callback need to be enabled, registered. This is the SI architecture. The callbacks are registered at a switch level. and handled at the MACsec object level. Right. So this callback is called by SCI adapter once the post completes for a given MACsec ID. Okay, with the MACsec post. So that's the flow. So I'll go to the workflow, but essentially system comes up, switch create happens, it registers the callback if there is a MACsec of interest, does and creates the MACsec object creation, triggers by setting the boot true, and once the MACsec completes, callback happens. Callback happens, NOS retrieves the status. If the status is passed, then everything good. If the status is failed, then it queries all the ports serviced by the MACsec ID to find which port or all ports have failed status. Okay, so that's the workflow, and this is what I have captured. And again, there is a little bit implementation specific tightness, and I'll request again Dipankar to you to help me clean this up a little bit. So step one, switch create is complete and post completion callback registration happens. MACsec object creation is complete. I feel, Dipankar, this is not needed. Step three.
I do agree.
Right. So if you can add comment to that, I'll remove it. And once this is done, then MACsec object with post attribute is set to true. This will trigger post on all the ports hosted by the engine. Okay. Once the post is completed on all the ports hosted by the MACsec engine, registered post MACsec callback will be called by the SCI adapter. If the status is fail, NOS must read the post status of all the ports hosted by the engine to find out which port has failed. For all MACsec port objects, this is just where the list is. So here's the list, which is for a given MACsec object, and one should trigger a read of the status. Now there is a subtlety here, which can be a little confusing. If you see that once we trigger the post completes, right? Now we are delegating a job to the operating system that once the post is complete, please go ahead and mark the status as false. Okay, that that post is complete. It's really is not going to make any difference because typically post is run during the init time. So even if it does not, marks as false, the problem is that then how do you know that this post is completed? Is this in a past state, failed state? So there's a little bit ambiguity, and I couldn't come up with this. Becomes like a sort of a state machine. I didn't want it to put a state machine inside. It's kind of not a good idea. So I have left it for NOS to make sure once the post completes, please mark the status as false, right? And after that, if the post has not been triggered again, the status can be queried by using the existing status attributes, right? The status is always available after system is up. But this one, I feel that, it's not that big a deal that NOS, once triggers the post, gets the callback as part of a callback handling, gets the status and also sets the status, the attribute of the trigger as false. So that's the only thing which I feel is a little bit not very, very elegant, but it works and it's less complex. I think that's all I have. Any questions on this?
I have a question. So you are meaning that the MACsec, when the post is running, so all the MACsec ports has to be in the down state, right? So there's two issues here. The one issue is our chassis can be set into the FIPS enable or FIPS disable mode, right? So we need the distinguishing. So when the FIPS is disabled, so there's nothing need for the post to be wrong, right? Because that doesn't need any FIPS compliant. So in that case, so we need some distinguish between that is FIPS enabled in the chassis or FIPS is disabled on the chassis. So that's the first thing. The second thing is the when you make the port becomes a MACsec port, that's when the configuration is applied to a physical port, right? So normally a port would already be in the up state. So does that mean that when we are triggering the post command, so then the hardware will put this MACsec port into a down state automatically? That's get triggered by the post. That's my question for this one.
Yeah, no, I think both are very good questions. So, and I couldn't see who is talking. May I know who is talking?
I'm Umil from the Nokia.
Okay, all right, okay. So yeah, so first question, I think that, and I was thinking about it. I was not very sure. So let me try to replay your question and see if I understand. So what you're saying, in a system, uh, even though may have FIPS module, but may not be unable for FIPS, right? And in that case, the behavior by the library may be different. There might be some actions which are should not be done by SDK, right? In that case, how do we distinguish that those actions to be done or not done at a chassis level? Is that the question?
Yes, some kind of this is similar like this. Is there's if the FIPS is not enabled, right? Then I don't think we need to run any post at all, right? Because even this port is
So
not.
there is a MACsec or IPsec attribute enable post, and I think its default value is false, which means that normally if you don't want to enable this post, then you just it's backward compatible. Otherwise, you set to true, it will start a post. Otherwise, it doesn't stop a post. That is my understanding.
Yeah, but I think, Gohan, I think maybe the question is that if the FIPS is enabled, then SDK may want to take some actions related to MACsec port or a physical port. Okay, and that may be implementation specific. And that may be needed even before we enable we trigger the post.
What is this enable the post? That's a whole MACsec. That's operating as a MACsec object, right? So
correct. No. So let me give a specific implementation example. So let's say that when we are running the MACsec post, the physical port is already up, okay, and physical port may also be forwarding traffic, right? Because the MACsec is configured in a bypass mode in the init. Now, when we run a post, there may be a requirement that physical port should not be running traffic at that point of time, right? If that module, if that component, if that chassis is FIPS enabled, and that may be a hardware implementation specific detail. I think question is that how do we distinguish? And there's just one example, and I don't know. I really don't know. I'm just making an example. How do we know that even before we run the post to differentiate between this situation? And I really don't know if this is a good example or a bad example.
Yeah.
Is this the question you were having?
Are you asking me or ask a
Yeah, asking you. Yeah.
Yeah. So I think we need to yeah, even we have a chassis right now. It's we boot up, and then let's assume there's no MACsec configuration. So all the ports are in the physical port, and it should be up and passing traffic, right? And then at this point, I want to configure the MACsec on this port. So I load some configuration, and then add this port into with the MACsec configuration. So now we will create the MACsec port, some action from the side level. So, but this also should have some distinguishing. Is do we need post that always in this case, or only? Yeah, I think we need to do only if the FIPS is enabled on that chassis, right? So if the FIPS is not enabled, I don't see any reason that we need to run this post test, or we can discuss this. We will always run no matter what to make sure this chassis, or the algorithm is already FIPS compliant, right? So even we are not enable FIPS. So which one? To me, that seems doesn't make much sense. But should we enforce that, or?
No. I think if there's no requirement, right? So if there's you no need to FIPS, then you don't need to run the post, right? So
We don't need to run post. Yes,
yeah.
that's what I am thinking. So we need some code. That should be the application level. Make some judgment. Do we need a post or not? Right. So that we can do. I think because we have configuration for the FIPS in the database, we can do a little bit more work there to make that happen. So, but my another question is okay, let's say FIPS is enabled, right? So but the port is in the physical port mode and passing traffic. But now we add this port to be a MACsec port. So now we trigger the post. And from this document, meaning that then this MACsec port has to be in the down state, right? So meaning this port will automatically becomes a down and blocking all the traffic until our post is finished. And then it will depend on the post result. It will enable the traffic, make the port up, or keep the port is down if the post test failed. So
I think we need to clarify this down things, right? So is this the physical port down, or is this a logical down, right? So
yeah, it's a MACsec port down, right? And as I said, that there is no upper state. Let me go up, right? So this is the MACsec port, not the physical port.
So can I? So I just was trying to figure this out. So if we do a thought experiment of two systems and consider the system one in which you have to run the post. If you run the post, the traffic gets disrupted. And the second system is one in which not just the traffic doesn't get disrupted, you actually have to configure the port before you can run the post. So in the first case, I would imagine the best solution if you have to run post, if the system is configured to run post, it runs the post during system initialization and maintains the state before even, or at least a security engine initialization, so that it does not disrupt ongoing traffic once a port has come up. And in the second case, after the configuration, only the post can be run and it doesn't disrupt traffic. In that case, you want to run the post after the port has been configured, right?
I guess in general, it is reasonable to impose restrictions on when you can run ports.
And if I have to choose, I would say that doing it at initialization is probably the preferred way, right? It's the least.
Right, because I mean, it is not natural for a system to be just working, passing traffic, and somebody decides to come and turn on FIPS. I mean, if SI implementation chooses to support it, sure, go ahead. But
and in that case, we probably don't even need the NOS to trigger the post, right? It could be part of the system initialization.
Right. So, I mean, as long as you get a basic, you can initiate post at some point in the bring up, whether it's a basic bring up or whether it is a specific port bring up or engine bring up. And you don't need it to be, you don't necessarily need an ability to trigger it anytime when a fully working system. You could say it's only available in a certain state. And that could be an implementation choice. I don't know if the spec needs to lock that down. because we don't need to suddenly trigger post on a fully working system.
No, are you saying that even if we don't enable the MACsec, when we do the switch initialization, we're also doing the post? Is that what you're
It doesn't
saying?
need to. No, it doesn't need
or-
to. What I'm saying is that you can restrict post from being initiated once you are past a certain point. Of course, you can also decide not to run post if if post is disabled, attribute is disabled, you shouldn't run post. But if you decide to run post, the SI can still say, no, it cannot run post at this point because you are beyond a certain point.
No, but my question is like, do we, if for example, I just create a switch, right? So for example, I don't even initialize the MACsec, but are we saying that in that case, because of the chip has a MACsec engine, so, it actually can do the post. And then after that, it returns the results. Hey, the post is passing. Then when we enable the MACsec, we no longer to do the post because it has been checked at the switch initialization time. Is that what we're saying here? Is that even possible? I mean, I don't know, like, okay, so because with this post, do we have to, do it after security essay created? So then we do the post, or, this, it does not matter.
I'm not saying that. I mean, I guess if what I was saying is it doesn't need to run post, and maybe it shouldn't if it is disabled. But maybe that's an implementation choice. But what I'm saying is, if somebody says run post and you're past a certain point in operationalizing your switch, you could say no, it's not supported at that point. And that's what I was saying is that
So
then you avoid all these scenarios.
What does a certain point mean?
What's that?
What do you mean by certain point?
Meaning, let's say you initialized and ports are up, and then somebody tries to come and say run post, and you say not supported at this point.
But the ports will be up, right? I mean, when you create the switch, the system will come up in a bypass mode.
Right. So then you could say, at that point say, if you could say you're not going to support post at that point.
So
you
this
could say it's only supported when the port is. I mean,
this be
the
solved?
usage scenarios where post is run on these systems that support FIPS don't call for it to be turned on at any point, every single point. I mean, it's most of the time it is really you do it at bring up time and then you don't do it again.
So I think the question is, and what Guhan is also trying to understand, do we do it even before the MACsec engine is initialized or MACsec object, at least in size, created? Do we do it way before than that?
It could work. I mean, you could do it as part of switch create and have the result available for query later.
So that is kind of outside SI, right? And inside
Right.
SI, we could, I mean, maybe this is too disruptive, but if we had an attribute for the MACsec object that says enable post as opposed to a trigger, then when the object is created with that attribute set, then the post is run.
I mean, that can definitely be a more advanced implementation for sure, right? I mean, that could, or it could be run in advance, and when you actually trigger the attribute, you just get the result of what was run.
Yeah, both should work. Yeah.
Yeah.
So are we saying like one option is that when we do the side switch creation, if the switch have the MACsec block, it will do the post. We can say, okay, let's say enable the post, right? So when we create a switch, we pass a parameter, say, hey, enable the post, and then If that's the case, then at the switch initialization, you will enable the post. If the post doesn't fail, sorry, if the post doesn't pass, then the switch creation fail. So are we saying that is now?
No, I think the maxsec it should maintain a state which will force the maxsec to be not enabled for that maxsec object. So the
Come
maxsec
again?
object creation potentially can fail, right? But not the switch creation.
Oh, okay, all right. But then in that case, we need to know, like, have a notification say, hey, in this case, switch, even though your switch creation success, but your maxsec doesn't pass, you cannot really use the maxsec, right? So
That's a possibility. I mean, but you can have multiple maxsec engines in a switch, right? So then one of them could pass, the other could fail, and so on. So the other possibility is that you will allow the maxsec creation, but you maintain a state in it in which you do not allow any ports to be attached to it or something like that. So
Right. So what you want is if you specifically request post as part of your switch create or whatever, right? In that case, then if the post fails, it is fair to say none of the maxsec engines are available for use, and you can still allow the initialization to complete. I think what you don't want though is you don't want to run post by default, even if the application didn't request, because then you might be in a situation where those maxsec engines become unavailable, even if this application is not running in a fixed mode, right?
So does that mean that the post test is running just after the system reboot when we are creating the switch?
I mean, if you request it, right? I mean, the attribute is there. Can you request it? Can you request it at switch level, or does it only need to be requested at a much more granular level?
Yeah, but my question is let's say we don't have any maxsec configuration on the chassis yet. So after reboot and FIPS is enabled, that is fine, right? So at that time, does the maxsec engine has any corresponding maxsec ports, or there nothing until you configure the maxsec on the port? That's my concern. If there's no port, then the post won't have any valid result, right? Or there's something I'm missing.
Yeah, until we configure, we don't have any ports, right? So I think we can have it enabled as part of this object itself, right, Shrikant? That should be good enough, because if the maxsec, when you create the first maxsec object, right? If it's enabled, we'll do it. Otherwise, by default, it's disabled, right? That's what Gohan.
Yeah. So then, meaning the post is running not at the boot time, but is on the configuration. When we have a maxsec configuration, at the first configuration, we can. But even the first configuration is you still have problem, right? Because if the first port we only have one maxsec port until we may have 10 maxsec ports to that engine, right? Until we configure one by one, should we run the post again for each port, or we should do at a certain point once, right? That's my question.
Yeah, so that is run at the engine level. So if there is a requirement for maxsec port to be configured, then the workflow will be you do the switch create, the maxsec object create, and then the maxsec port create, right? And once all that is done, then you set the trigger, the Boolean to true, that run post, and that post
run
is
post.
at the
Okay.
maxsec object level. But I had another question to the previous discussion, which is at the switch create level. I mean, if there is a system design where you need to run post during the switch create, in Psi it's very easy to do. All I have to do is put the trigger, same trigger at the switch level, and then you will get callback for every engine, right? Because switch create, you have to also register the callback. So let's go down. That's something very easy for me to do. If that's so this is the partition callback.
Yeah. Right. So I think I'm kind of looking at it from two things, right? One is how much does an application really exercise in its normal function? And then what do you need to do when you go to your lab and you need to pass your compliance and everything?
Right.
For the second one, maybe I may be wrong, but I'm thinking for the second part, where you're going to the lab, ideal scenario is you boot up the switch, you run your post for whatever, and you're done, independent of what configuration exists or doesn't exist on the system. Is that not what we want? Or am I oversimplifying this?
I think it doesn't it depend on the hardware implementation as well?
Well, the hardware's already there, right? Again, you're right. It's a hardware implementation dependent thing, but from a lab point of view, if there is an implementation that supports it,
if it supports it, then I think we should
right.
see.
Having it be available is very good.
At a switch level makes sense, right? And then
Right.
you can query that attribute to figure out. We have a concept of capability query. Then you can query that attribute whether a given hardware supports at a switch level post, right? And then if it does, then you can trigger it by setting that bool to true at a switch level. So before even anything, but that makes an assumption that hardware is designed in a way where you don't need to create MACsec ports, you don't have to initialize MACsec engine, you don't have to do nothing to run the post on the MACsec.
Right. I mean, here the application knows its hardware. You could run it in that fashion. I'm not saying that you couldn't also do at an engine level and a port level, but this is definitely helpful.
Yeah, I'm agreeing with. I'm just stating that there is a hardware design which need to be kept in mind, and as long as we are okay, we should be able to add that.
So I mean, so then the next is if this is there, I mean, this is the simplest for an application to adopt. Of course, the application can do more sophisticated things like have code that enables and sets post attributes at the time of MACsec port creation and other things. It could do that, but that's a little more sophisticated work and a little more application work. I mean, it could be done, but that doesn't have to be the baseline implementation.
Right. So I think let's do one thing. I think, again, I couldn't tell who's speaking. Sorry for that. If you can add comment for this use case, then I will add attribute at a switch level and also describe the capability query that how NOS should take a decision whether it should trigger post at a switch level, coarse granularity, or at a fine granularity at an engine level.
Got it.
Yeah. So just add comment, and I'm gonna. That's how in Psi, I think that's fairly easy to do. That's what all I'm saying.
Okay.
Yeah. Well, now given hardware, how it's easy or not, that I have no idea.
Right, and a specific hardware could say that attribute is not supported at switch level.
Exactly.
Okay, that's one approach, right? So the other approach is, you know, I don't know, like if we can do at the switch level, then we can also do at the create MACsec level, right? So because so this part I'm a little bit confused because if we look at the step example, they're saying, hey, you know, you have the step 1 create switch, you know, step 2 create MACsec object. If we can do at the switch create level, we can also do at you know, the MACsec object level. So we can also enable post and get notification, right? So I think that maybe, you know, one thing that say if we want to change the FIPS, then if we only do switch level, then you know we have to if we want to enable and disable the FIPS dynamically, then we have to say, hey, you know, we have to, you know, destruct the switch, which means that cause traffic disruption. But if we do at the step 2, like the MACsec object level, then you know, maybe, you know, the software can say, oh, if we want to enable the FIPS, we can, you know, destroy the MACsec object, and then and then create it again, right? So then, you know, whatever the MACsec object has been created, then those will have disruption, but not all the ports, right? So or you so there. But I think the current post is done at step 4. I don't know why it's done step 4. Why cannot we do it in step 2?
No, I think it is done in step 2. This one, Dipankar earlier pointed out, this is not needed. So this step will go away.
Okay.
Yeah, it is done at step 2 only. We don't need this. MaxSec port creation is not needed.
Okay. So the post is only giving like the status, but we don't know which port is having issue. How do we know which port is having issue?
No. So the callback is at the MaxSec object level, and then each port has a status. Let me go. Each port has a status. Let's go here. So NOS has to read the port list so there's a port list for the MaxSec object. It has all the MaxSec ports. So you just do a walkthrough for reading the status. This is what I've explained in the here.
Got it.
This.
Is this only need to be done at the initialization time, or this has to be done periodically?
Only when the post completes initialization time, as part of the callback.
Okay. So we don't have to periodically check the engine status, make sure it's staying compliant. Do we have that kind of requirement? But I understand the post. It seems like a disruptive process, right? So therefore, but I was wondering, like, if somehow, I don't know if that's a possibility, right? So if somehow the conversion change and the port is no longer in the compliance status, do we get a notification, or how do we handle that, or do we have?
Yeah, that's a good question. So this is the first time I'm hearing that requirement. So is that a requirement that when the system is past post and is up and running, then after that the system may be not FIPS compliant and post may result in failure? We don't run periodic post. Post is destructive, right?
Yeah.
No, I think that the expectation is that once you run post, until everything's resets, after that, of the specific engine, or if you run it at the switch level, the switch, it remains in that compliant state, that it is not, that the algorithm implementations haven't changed and it is continuing to run in that state, which is compliant. Right, because you booted up in a FIPS compliant mode, or you started up in an engine in a FIPS compliant mode, it's got to stay in that mode. I mean, that is the expectation. I mean, even if you run post for a purely software crypto module, right? That, I mean, you cannot subsequently go replace the module.
I have to jump on a different meeting.
Yeah.
Would it be okay if we?
I think we should probably schedule a separate session. This is very, I think, a big change, right? So let's try to schedule another meeting. Maybe off the cycle, and let's try to join that.
All right. Okay. Let's do that. So do an offline meeting, Guan, or you want to just continue in the next session?
From Broadcom. Okay.
Yeah, I mean, suggestion, do we have Jinda for the next week, or?
Yeah. We could continue the next session.
Okay, then let's continue next week. Okay.
Okay, we'll continue next week. All right. Thank you, guys. Thanks. Bye.
Thanks, everyone.
Thank you.